Imagine it's a hot summer's night. It's 3 a.m. in the morning. Difficult to get back to sleep at the best of times. And then... Insects can be so annoying. I'm sure that every one of you, like me, have at some stage been at their wits' end because of an insect. Not only do mozzies keep us awake, we inhale flies. Wasps disturb our barbecues. We find grubs in our flour. And insects eat the fruit that we try to grow in our garden. And what do we do about it? We spray. Australians spend about nearly half a billion dollars on pesticides every year. 1/3 of that, to my surprise, goes to household pesticides. 2/3 are used in crops. And that has been increasing steadily over the last few decades. And the main reason for that is the way we grow crops. Monocultures are particularly prone to outbreaks of pest insects. Beneficial insects that can help with the control of these pests struggle to exist in those environments due to lack of food choices. And they don't go well with pesticides and herbicides either. So, as a consequence, it gets worse really, because our pest insects have a tendency to evolve resistance against pesticides. And what do? Well, when we notice first, we up the dose, and then we develop a new, stronger, more harmful insecticide. And that, as a consequence of that, and with more and more land under cultivation, many agricultural areas have now turned into what I call biological deserts. There is hardly any biodiversity left there. And I can illustrate that by talking about bees. Studies in the USA and in Europe have shown that locally, in very large areas, 50% of the bee species have disappeared. Other studies have looked at nature reserves in agricultural matrices and have shown, both in Puerto Rico, in Germany and in Holland, and in the UK, that 70% of the insect biomass has disappeared out of those nature reserves. Now, that is a real worry, because in normal healthy ecosystems, insects represent 75% of the animal biomass. And that 75% of animal biomass, that 3/4 of animal biomass, is food for birds, for reptiles, for amphibians, for small mammals like bats and rodents. And that's why they are disappearing out of our landscapes. So it's time that we appreciate how important insects really are. They are the key drivers in terrestrial and aquatic ecosystems. It's also important that we realize that insects are important to humans. You may not like maggots, but maggots make sure that carcasses disappear quickly from our environment and don't turn into rotting, stinking health hazards. Ladybirds, lacewings, and hoverflies eat aphids. They're voracious aphid eaters. Parasitoid wasps parasitize a range of aphids and caterpillars in the landscape and in our crops. Ants can remove 90% of weed seeds from an agricultural area. And soil insects are hugely important for 3 reasons, really. First, they tunnel into the soil, allowing air and water to penetrate it. Secondly, they incorporate organic matter. And that means that nutrients get into the soil, but also that the soil has better possibilities to retain water. And thirdly, termites and ants can fix nitrogen. It's not only legumes, it's also termites and ants. And it's been shown that these animals in a grain field can supply 1/3 of the urea that a farmer needs to grow grains. 1/3. That is an economic value, because fertilizer is the most expensive thing that a grain grower buys. Okay, so And because of the importance of insects on all levels, we need to rethink the way that we grow crops and deal with insect pests. And that's what we're doing here at the Waite. What we're doing is we're trying to reduce the use of insecticides and improve the health of the crop environment for insects. For example, we develop pheromone traps to better control citrus gall wasps. We develop sterile insect techniques to control fruit fly. We are studying a range of parasitoids to make them better perform in and know their value in, for instance, hot greenhouses for the control of greenhouse whitefly. In grapevine, we study the parasitoids of light brown apple moth, and for the control of Russian wheat aphid. So my research fits into that area. We study bees and crop pollination. Now, when I talk about bees, most of you might think about honeybees. And that's true, honeybees are the most important crop pollinators in the world. But I happen to like these guys. And these are a few examples of Australian native bees, South Australian native bees, but there are about 2,000 species in Australia. We don't even know all the species yet, but what we do know about them is that they are hugely important for the pollination of Australian native plants and that they help pollinating Australian crops. And when you talk about crop pollination, 75% of crops benefit from insect pollination. Without that pollination, we would survive, no problem. But our menu would get rather dull. And it might not surprise you that insects are involved in the pollination of apples and almonds, but they are equally important in the pollination of tomato and zucchini. And then there are vegetables that only grow from seed. And those vegetables, there are many of them, they need insects for pollination, and they include leek and onion and fennel and celery and carrot. And then there's milk. A lot of our cows eat lucerne hay. And lucerne hay grows from seed. And that seed relies for 100% of production on bee pollination. So that is how important bees are for our menu. So my research group focuses on improving agricultural landscapes for crop pollination. Now crops, pollination-dependent crops, can provide good food for bees. But it is rather one-sided food. It also lasts rather short and is gone fairly quickly. And then those bees need to get some food out of the environment, pollen and nectar. That's the thing. And so what we do is we look on the crops and we look on the plants around the crops and look where the bees go, honeybees and native bees alike. What sustains them? And we analyze, we use molecular analysis to analyze what pollen they bring back from the environment. And based on that, we produce a list of plants that the bees can use specific for the region and the crop. And then we could go to the grower and say, can you plant this, please? And the grower would say, what's in it for me? So what we also do is we look at the vegetation edge and look at how that vegetation edge impacts on the density of pollinators and the pollination surfaces. And what we find is that of a good edge of native vegetation, we can find effects up to 200 meters into the crop, which is really great. And we then go with our plant list to growers, and we also give them advice of how to plant it, how to maintain it, what it will cost, and also we plant demonstration plantings for them. And in the end, we hope that our research will help to bring some life back into our agricultural deserts. But changes in the way we grow our crops are not the responsibility of farmers. It's the responsibility of you and I, the consumers. And with changes in our behavior, we can change how crops are grown. And so what can we do? in our food choices to help slow down the decline of insects and other animals? Well, we can eat less meat, especially beef, because it's not very sustainable. We can grow our own vegetables or eat greenhouse-produced vegetables, because greenhouses are really efficient with space and nutrients and water. Or we can buy organically grown food. Now, organically grown food is not better for you than conventionally grown food, but it is better for the environment. Organic farms have higher soil health and larger animal and plant biodiversity on the farm. So buy organic if you can afford it. And then if you find a slug in your lettuce or a worm in your apple, appreciate it, because it shows that you've made the right choice. And also, hold off on those household insecticides. They are really detrimental to bees. They are absolutely bad for other beneficial insects, and they're not healthy for you either. And there are often other options to get rid of those pesky insects.